Okay, we're going to do a comparison between adding regular static meshes into the Unreal Engine world, and this is Unreal Engine 4.9, versus adding hierarchical instant static meshes. So we're going to take a look and see if there's a big performance difference between the two. So let's get started. We'll click play on here. And we have this set up. Every time we click the mouse button, it'll spawn actors. So if you look in the right hand corner there, you see we just spawned 2,500 actors. So that's 25 individual boxes. They do have textures, and you can see they're all separate and unique. They're actually, each one of them is a separate actor in the world. And also you can see we're looking at about, let's see here, we were about 100 frames per second. Now we're about 70, 80, 75, 80. And one of the big things to notice also is, let's take a look at some stats here. Here's the triangle draw. It's 145,000. Now the reason that it's lower is because we have a good LOD set up on the boxes, and LOD is level of detail, and so it's only going to show high detail up close. So we can kind of look at how that works. Let's turn on the color mode. So you can see the boxes in gray. Those are the boxes that are LOD 0, which is the highest quality. And then the red ones back there, if you see as we go closer, they move. So whatever is closest to you is high detail. The red ones back there at 50, and the green are, I think it's 25, and then I think it's purple back there, or blue, is at 0.12, or 12% of the detail. So if you don't have that set up correctly, the LOD, your frame rate will be even worse. Especially it really hammers the GPU, because what will happen is the triangle draw, you see that number that's moving a lot, it's at 153,000. That will go way up because you'll be so like say that one box right there, the gray one, just one of those boxes, let's say is approximately 100 triangles. So you take 100 triangles times, in this particular case, 2,500 actors. That's quite a bit. And then if you would go up to maybe 10,000 actors, and then you're showing all the triangles at one time, or processing all the triangles at one time, it's a lot more overhead. So LODs are super important when you're trying to get the best performance. So let's continue with our test, though, because this test is really between static meshes, which we just put in there, just a regular mesh that you can make, and hierarchical. So let's turn off this mode here, and then also let's turn off the color mode, get back to our regular. Sometimes you have to exit out and go back in in order for that color mode to start working again. Okay, so let's take a look at some. So we're at almost 100 frames per second. We're going to drop in 2,500 actors, and we're looking at about 75, 80. We're going to clear those out, and now we're going to drop in 5,600 actors. So which is incredible amount of actors. The Unreal Engine is an amazing engine. Look at that, incredible. And now we're at 40 frames, and now we're going to drop them out, and now we're going to drop in, let's see how many we got. I think it's 10,000, and we're looking at 25 frames for 10,000 actors. So if we look off and then we look back, it's got to process all those triangles. So still not bad. I mean, that's incredible. 10,000 actors on the screen at one time. And take it they're all the same, and take it they're very low poly or triangles. There's only 100 each. So if you had something really detailed, I don't think you'd get this many. So we're going to take those out. We'll keep going, and then we'll hop over and then take a look at the hierarchical, see how it does. So now we got, it's working a little bit. There's 15,000 actors. Now we're at 15, 16 frames per second, so it's really slowed down a lot. So it's 15,000 actors on the screen at one time. All right, let's clear those out. Let's keep going. let's let's see what this thing will do. Smoke the computer. Now, the computer that we're doing this on is a mid-size to low. It's an older computer, so maybe mid-size, a little lower than mid-size. So this is a good test comparison. All right, let's see what we got now. Yeah, it's struggling loading this many actors at a time. Takes a little bit of loading. So this is 22,000 actors. And now we're at, wow. I think the next one is 40,000. That's probably all we're going to be able to do because we're already at, it's unplayable. 1170 milliseconds. Wow. Yeah, so that would definitely be unplayable. So we're going to do one more, and then we're going to go look at the hierarchical. And I think this one's set at, this may be 40,000. I think this is the last one. If it'll even load it. It may lock up. No, it did it. It did it, and that's 30,000, but it's really taken a beating. It's amazing it can even process 40,000 actors all at one time. I mean, it's taken a beating, but hey, we can walk on them. So, yeah, here's another example of the LODs, how good they work. So if we're looking at it right here, so as we go back, it's going to keep calling out further and further. Okay, so let's go ahead and close out this test, and we're going to hop on over to the other test and see how good the hierarchical meshes can do with a large number of objects. All right, here we are with the hierarchical instant meshes, and this is on here. As you can, if you look to the right, you'll see that there's just 7 actors because all of these are stored as instances inside a blueprint. You create a blueprint, and I guess it stores them in there. But you can see, so this is 2,500 boxes, and actually these don't. Okay, actually I'm flying here. Hang on just a moment. Okay, so we have 2,500 boxes here, and you can see we're at, I think we're like at 80, 75, 80 frames on 2,500 boxes, and on this one we're at about 90, 95, 96, so already winning on the 2,500. So we're going to pause this. I'm going to bring in, we'll bring in 5,000 boxes, and then just kind of go up from there and see what it looks like. Okay, now we have, this is now 10,000 boxes, and we still at 95 frames. I know in 10,000 on the static meshes, it was going down pretty quick there. I think we were at 30 or 40 frames. So it looks like it's still staying up there pretty high, even with 10,000 boxes. And I definitely know on the I think at 10,000 we were at 25 frames, so doing a lot better on here. So let's crank it up. Let's go to the I think on 20,000 boxes on the static meshes we were barely like 5 or 6 or maybe 9 frames. It was barely going. So let's hit 20,000 and see what happens. We'll come right back. All right, we bumped it up to 40,000. So we're just going to go and see what 40,000 blocks. Phenomenal. Yeah, as you can already see, because the static meshes at 40, I think 20, we were I think at 20,000. It was at unplayable, 4 or 5 frames per second. Here is 40,000 individual boxes. That is unbelievable. And that is, we're still at the, seems like almost the same frame rate. We're almost at 100 frames. Phenomenal. So, in saying that, yeah, if you have to have a lot of objects on the screen, yeah, and there's no other way around it. You have to use the hierarchical instant meshes. Okay, so let's go ahead and pause. Let's bump it up. Let's go. Let's see how high we can go. All right, now we're back. Now we went from 40,000. Now we have 90,000 on the screen. So we have 90,000 boxes it's showing. Pretty phenomenal. It looks like the frames per second is about the same. So it may be that we can just keep going, and it's at some point it's just going to call the far back ones, and you can put as many as you want on here. That's phenomenal. So yeah, major difference between static meshes and the hierarchical. Yeah, I mean, if you have to have a lot, there's no doubt, because this is 90,000, and then with the static mesh actors, we got like 20. After like 10,000 is unplayable, and here we got 90,000. We're still at 100 FPS. So yeah, that sums it up. Hierarchical meshes or instant meshes is the only way to go if you want a lot of the same objects on the screen at the same time. If you have any questions, or if you have any info that you know that different, please feel free to leave it in the comments below. I'd love to hear from you.